We're going to take a look at our very first algorithm and understand a lot of basic steps on how you write algorithms. In order to write an algorithm, you need to have a few things in mind. You always need to get 0 or more inputs, do some calculations or processing, and then print the result. And each of this has to be done in definite number of steps. The steps should be in a particular well-ordered manner, and then it should begin and it should have an end. So let us say I need to write an algorithm to find the sum of two numbers. So the first step I do is I say step 1 and then I say start. In order to find the sum of two numbers, I need to read two numbers and then store the resultant sum. So let me call the first number, or let me store the first number in A, let me store the second number in B, and the result of A plus B in a memory location called as sum. So A is a variable, it represents a memory location. B is also a variable, it represents a memory location. Sum is also a variable which represents the third memory location. So in order to calculate the sum, I need three memory locations A, B and sum. In place of A, I could give it the name X, Y and sum. But give meaningful names to memory locations so you know the purpose of why you tend to use them. So the first step is start. In order to calculate the value of sum, I need to ask the user to enter or input the value of A and B. So what do I say? Read two numbers into memory locations called A and B. How do I do that? In algorithms, I use the language input A comma B. Input means I am asking the user to enter the values from the keyboard. Let us say I enter the value of A as 20 and B as 10. Alright. So I am inputting the value of A and B as 20 and 10 in step number 2. So this is how you write. Step number 1, start. Step number 2, whatever is in this bracket is used to describe what you are trying to do here. So this is in an English-like language telling you that you are trying to input two numbers A and B into two memory locations with this name A and B. Let us say I have entered 20 and 10. In third step, I am required to calculate or compute the sum. How do I compute the sum? I can say sum is A plus B, or sum is assigned the value of A plus B. So here it is. Sum is assigned the value A plus B. When sum is assigned A plus B, sum will now be equal to 30. Alright, sum is now equal to 30. Now once in step number 3 I have calculated the sum, what do I need to do? I need to display the sum. So I need to display the result. How do I do that? I say print sum, show sum, output sum, all mean the same. So here I am saying output sum. So if this is your screen, the result 30 is going to be displayed on the output. And then finally step number 5, it is end of the algorithm, and I say end, I write it as exit. So here if you see, I have followed the basic rules for writing an algorithm. I have done it in a step-by-step manner. The steps are in a well-ordered sequence. There are finite number of steps. The solution is found in a finite amount of time. None of the step is not clear. Every step is crystal clear what it is meant to do. Now once you write an algorithm, there is no guarantee that the answer is correct. So you have to go step by step. Step 1, start, nothing is happening. Step 2, input values into A and B. So here what I am going to do is, let us say I have entered 20 and 10. The value in sum right now is, I do not know, I don't care. Step number 3, find the value of sum. A and B still remain 20 and 10, but sum now becomes 30. That is step number 3. Step number 4, display the result. Here it is, I am displaying the result. Step number 5, end of the algorithm, I am doing as exit. So if you see here, the steps were in a definite order. Before input, if I had written compute A plus B, I would not be able to get the correct sum because I have not read or accepted any values from the user into A and B. So a few things you need to know. This testing of the memory location at each step is known as a dry run. I can only know when my logic is correct when I do a table and I try to see at each step how did the contents of the memory location change. Suppose I had interchanged and I had put some before input, I would have definitely not got the correct result as 30. Just try exchanging step 2 with step 3. If you do step 3 before step 2, you will get a meaningless output. So this is how you do dry run or how you test your logic. This is a table you should need to draw. The table will contain columns which will list all the variables or memory locations which are changing, and at each step you will see whether the change makes sense. If the change doesn't make sense, that means your logic or solution is incorrect. It is your responsibility to test your logic. Don't ask me or anybody to test your logic. You should be able to draw a table, write down the step number 1, 2, 3, 4 and 5, and at each step see whether you are getting the correct result. It is your job to test the logic. Nobody is going to test it for you. You should develop this particular skill to test your logic. Do not expect spoon feeding in 11th and 12th standard that somebody is going to test it for you. I have already told you this. You should not request as a rule anybody to test your logic. You should be able to draw columns, write down the steps, and at each step find out what was the problem. So using this simple algorithm to add two numbers, I showed you what is the algorithm. Have number of steps, have a start, have a stop. At each step, be very clear what you're doing. Always there's going to be an input, there is going to be a calculation, and then there's going to be an output. If you remember the very first lecture of computers, computer is a device which takes input, processes that input here and produces the output. That is exactly what we are doing in an algorithm. The sequence of the steps is very important. They have to be in the right order. If you try to shift the order, you will land in problem.